So what is Creo Simulation Live? It's technology that's been embedded in Creo, and it comes from the partnership between ANSYS and PTC. Okay, so this is was a game changer, and still is, with respect to real-time analysis, getting results really quickly on screen, and allowing that to influence our design as we're designing, rather than having to wait days and weeks before a particular specialist to look at the issue. Okay, so there's lots of different areas where this can work. Primarily, I guess most people will be looking at the structural analysis, but there are other areas that we can look at, like fluid flow and thermal and so on. And I would point out at this point, what's available in ANSYS is above and beyond what's available in Creo, but over time that gap will hopefully narrow, and we'll see more and more functionality coming into Creo. Okay, but there are a whole bunch of capabilities. Okay, so you can see them all listed there. Okay, and again, these are capabilities in ANSYS, not necessarily all in Creo. So we don't have electromagnetics or multiphysics in Creo just yet. But anyway, that technology is being used and embedded in Creo. So the Creo Simulation Live extension, basically every designer needs it. Okay, that helps them, going to help their design. If they're designing something, a structure, an individual part for to determine its performance, if it's sufficient for what they're doing, then they really need it these days to ensure that their design is up to scratch straight away. They don't need to guess. They can make these decisions themselves earlier in the process. Okay, so a whole bunch of other benefits. Definitely the main one is streamlining things. Okay, we're not having to involve multiple people. The designer can do it. We can, based on that, we can then reduce the design cycle, development costs, and so on. All right, so it's a relatively new paradigm, although it's been around for a little while. Yeah, basically inside Creo, we're looking at structural, static structural analysis, thermals, and modal simulation. Yeah, and if we just go a little bit further, very fast, as we talked about, very easy to use, and you'll see that. We can make changes to our designs very quickly, and then the results update. And it's powered by ANSYS, the world leader in FEA. Okay, so structural, thermal, modal, and we also have fluid, which we'll get to in a moment. Okay, so we'll jump onto Creo. All right, so I've got a model here. I just want to show you in the context of this model. So we've got a brake disc here. We've got the caliper over here. We want to look at maybe designing this and thinking about some design changes that we might make. Okay, so what I'm going to first do is I'm going to open up this assembly. Okay, and basically just going to go back to a previous iteration of this. So what I'm showing here is using design exploration extension, which just allows us to look at different configurations quickly. But this analysis has already been set up for us. So if I simply swap to the live simulation tab, you can see we've got some loads and some constraints already added. Okay, so we've got some constraints, a load, and we can just start to simulate that without doing anything. So we've also got a material properties assigned to this model. Okay, and this is going away, and it's solving now. So we can see Here, if I set it to megapascals, we can, we can see the results on screen pretty quickly. And this is like an iterative process, if I can say that properly. Basically, it solves and then solves again, and it sort of iterates itself towards a solution, okay? And so looking here around a value of 140 megapascals for this particular design based on the loads and constraints and materials placed in. If we, go and look at a different variation of design. So imagine we've gone back, we've changed our design, we've done this, we've done that, and we come back. And then the analysis, I didn't need to press anything here, it just updates, okay? So now we're down to roughly 110 megapascals. And then we might think, okay, I want to make some more changes. I'll go and try and reduce the material here, adding all those holes in the center. And then we're going to go ahead and run that analysis again. All right, and so that's then developing that solution. So I guess in this case, we've decided that, we need to reduce the material. So we're happy for the stress to go a little bit higher than what it was when it was 110. So we're removing the material, it's gone up to 125. I think we started at 140. So we've reduced the stress in this design. We've also made it simpler. Before it was an assembly, now it's a part. It's basically a laser cut part, right? Or if you know what I mean, it's a single plate. It's not multiple components, there's no welding. So that's also a benefit, okay? All right, so this model was already set up. But what if we look at, just bear with me a sec. Okay, so what if we, we'll close out of this and we'll look at a really simple model and just setting that up from scratch. Okay, so here, straight away, if I go into the live simulation, before where I saw some loads and constraints already added, we don't have anything now, okay? If we look at, and this is Creo 8 that we're looking at here, if we look at this in here, we've got a material assigned, which is steel. So what we really need to do here is constrain this model. So what I'm going to do is say, okay, fix this back surface and then put some constraints in to represent the bolts that are going to be there, okay? So we're trying to represent the real world the best way we can. And then what I'm going to do is on this face here, I'm going to put a load in. Now you can see down the bottom here, it's telling me the direction. So I want to put it in the negative Y direction of, let's say, 100 newtons. Okay. And then as soon as I've done that, I've gone from a model which wasn't defined, didn't have any FEA. After just a few clicks, I've gone away and I've managed to get a result there. Okay, so that's 100 newtons. It's obviously quite a high stress. So this is the where the parametric nature of things comes in. If we were to maybe try and change. I'm not sure if anyone can see the flashing that's happening on the screen here, but I can.
The video's coming through okay, Ben. It's not flashing or anything. So.
It is flashing for me, yeah, which is a bit of a pain. All right, so I'll just try and so it's not that one. So the width here is 3. If we had 540 megapascals or something before, if we change this to 6, okay, and I just complete that. All right, so it goes away now, but as soon as I'm finished with that, it goes away and starts to remesh. recalculate the results. Okay, so now we've reduced the stress basically nearly by half, which, you know, intuitively makes sense. We've got more material there able to handle that load, the result comes down. Okay.